My name is Victor Monga. I'm serving as Vice Chairman of the board. For those of you who might be interested in learning more about me, please connect me over LinkedIn and or Twitter. Virtue Testing is a California incorporated organization. It's a 501c3 tax-exempt nonprofit. That means all donations paid to VT are tax deductible. VT was founded on simple concepts like curiosity and community. We service 3 centers of excellence. Education is to offer the community to speak, collaborate, hands-on learning, and grow. This helps our community members to amplify their skills to advance their professional careers. Charity is to offer fiscal sponsorships to groups and missions who do not have non-profit legal status. We enable them so they can start accepting tax-deductible donations without having to build and maintain non-profit legal status. Innovation is to work with our partners to crowd test new security platform integrations. We believe state-of-the-art technology can and should be accessible by anyone. We build partnerships with other organizations to collaborate and enhance experience for our members.
Join our new VT Cybersecurity Researchers Program. This initiative allows cybersecurity researchers to beneficiate from VT's network. Through this program, researchers will access community support, knowledge base, and reach a large audience. This will enable promotion and feedback on your project. Through our diverse community, you can leverage business and financial partners, or simply brainstorm ideas with peers. We are only accepting a limited amount of applications. Email contact@virtuallytesting.com if you're interested.
Today we have Tanvi Gawade with us. She's a research student and she will be presenting and talking about her research. Tanvi, welcome to our show.
Thank you, Victor. Thank you for having me on the show. Hi, everyone. This is Tanvi here, and I'm a fresh graduate student from Masters of Information Systems, studying in California State University, Los Angeles. And today here, I am going to present you a small sneak peek into my data journey and how I streamline my career towards data analytics. So the agenda for today would be my data journey, of course, a sneak peek into how I stumbled upon data analytics and turned into passion. So I never knew that this would be my dream streamlined career. And this is where I'm going to discuss about on this point. The second would be research representation on how and what kind of research we did in the field of data analytics, introduction to big data science. So over here, we're going to talk about exploratory data analysis and machine learning approach for prediction of length of stay for pediatric inpatient database. And of course, my future prospects, turning my dream into passion for becoming a successful data scientist, predictive analytics. Yeah, so a little bit about me. I'm passionate about data analytics. I love to explore the relationship between numbers and translate digits into actionable, meaningful stories, which helps the businesses to take their decisions and earn some profit and meet their goals, the key performance indicators. To go ahead about my education journey, I did my bachelor's in electronics and telecommunications from Pune University, India, and completed it in the year 2012. So this was more of studying electronics as well as some kind of coding. This involved majorly the microprocessors, microcontrollers, and more of the hardware settings and how we integrated it with the software development kits. Later, I wanted to streamline my career in data analytics, and therefore I came to United States to pursue my Master of Science in Information Systems, California State University, Los Angeles. Over here, I got a chance to put my hands on practical implementation of data analytics, specifically with the tools of big data science and business intelligence tools such as Tableau, Power BI, as well as the cloud platforms such as Azure Machine Learning and AWS. My data journey and how it all started. To start with my data analytics journey, I took my career and started my course with bachelor's in electronics and telecommunications back in India. So over here, we implemented mainly on the hardware settings, which involved microprocessors and microcontrollers. And this is where we learned how we would integrate the software coding technology with the hardware. We, of course, came in touch with many of the electrical components where optical communication systems, television, and data communication work involved a lot. After completing my electronics and telecommunications, I got a chance to associate with Accenture as a senior analyst. And my main job over here was to deal with the data management team. I was a part of data management team wherein we had to work closely with the web application development team. And the client, of course, over there was telecommunication client. So I could implement my knowledge, which I gained in electronics and telecommunications within Accenture for the particular client. So over here, what we did was we got data from various sources. It was structured, unstructured, and our main job was to take the requirements from the web application development team and do the analysis on the data, extract and mask it using the SQL Server DB, and provide it to the testing teams wherein they could test the functionality of their web applications. So this is where I realized, working with data, that I got more intrigued, and I understood that, okay, this is something in which I can achieve my career and streamline my career in. So I worked with Accenture for 4.5 years, and I thought that I should push myself more and come out of my comfort zone in order to learn new technologies pertaining to big data, data engineering, and analytics. And this is when I decided that I am going to pursue my master's in information systems at California State University, Los Angeles. After coming to United States and starting my course, we did a couple of projects which made us involved more with the professors in the field of research that involved introduction to big data science, mostly with the distributed computing systems, which is a boom nowadays, Hadoop and Hive technology. And this is where we realized, with learning, covering most of the data sets, as in how you can derive insights, how you can impact the business decisions, what more you can do with the data. Of course, there is a lot of messy data that we have to deal with, and that is where data engineering came into picture. So this is where I got to put my hands on new technology, specifically to Tableau, statistical analysis, Power BI, and open source tools such as Python using Anaconda, and of course, introduction to machine learning technology. So I knew it here that this is my passion and this is where I want to streamline my career. After completing my course in information systems, I am currently working with Scale Capacity as a cloud engineer, working with AWS data solutions particularly. So not only are we working with the on-premise data related to analytics and deriving key insights for the business to take decisions, we are also helping customers to bring it on the cloud, from on-premise to the cloud, and continuing their journey for the data analytics. Mainly, we work with the IoT technology, where we can provide the solutions, architectural solutions based on Amazon Web Services to the client for their real-time incoming data with the help of all the AWS services that we have. This is the data journey, a sneak peek into how I tried to streamline my career into data. The certifications that I achieved while studying at California State University is Tableau Desktop Specialist 2020, AWS Cloud Practitioner, Business Intelligence Certification Program conducted by CSULA. And down the line, I'm seeking more certifications on cloud-based technologies specific to big data and data analytics. We did work on a number of projects while doing masters, but the main and the key project that I would like to share and worked on was on exploratory data analysis to understand the factors associated with the prediction of length of stay for the pediatric inpatient database. So the length of stay in hospitals, why did we choose this project? This is mainly because we believe that the length of stay is an indicator of efficiency for the care and hospital performance. At this stage, when we are having such crisis of COVID, I think it is something that we need to deal in more, and more number of people that are coming out for the research. This one aspect is something that would definitely help in the hospital performance, improvisation of the resources, and would definitely shorter the stay and consumption per discharge and cost saving. So the data set that we chose was the Healthcare Cost and Utilization Project. It is basically a family of healthcare databases that are created by the Federal State Industry Partnership and sponsored by the Agency for Healthcare Research and Quality. These database consists of many longitudinal data coming from different hospital care, both from private data organizations to the state level data organization, hospital associations. So we have around 3 million data records in our data set that we have worked on. We chose the project especially because it in future it helps in the research of health policies to know what are the cost and quality of health services that we can improvise upon. It can give an insight into those quality of health services. We can research and transform this research to a more informed decision making and improve healthcare delivery. Specifically to this data sets that we have, databases that we have, we chose the pediatric inpatient database, which is the largest publicly available all-payer inpatient care database. So inpatient care database as in what were the discharge dates. So the different elements that this consists of are the demographics from age, race, gender, as well as all the discharge information that the hospitals usually document. These are again supported by the Federal State Industry Partnership, and they abide by the HIPAA laws. This database consists of patients which are below the age of 20 years, and participating year is 2016. It also has a lot of data pertaining to neonatal age, that is the age that is less than 28 days. So this database basically consists of emergency department visits, ambulatory care services, and it's a large sample size and ideal for developing the national and regional estimates. This enabled us to analyze rare conditions such as congenital anomalies, as well as uncommon treatments such as organ transplantation. It does have the international classification of diseases standard, clinical coding standard that is used by the United States in their healthcare industry. Specifically to the pediatric database, it enables us to do the national and regional studies of common and rare pediatric conditions. This helped us identify, track, and analyze what are the trends in healthcare utilization, access, charges, qualities, and outcomes. We mainly used with the help of exploratory data analysis using the business intelligence software tool that is Tableau. So our first objective was to present a dashboard, an interactive dashboard that the healthcare management teams can use to quickly visualize where their problem areas were. What were the patterns of emergency departments? What were the type of diseases that they were encountering on weekends and weekdays over the entire year of 2016? So they can further drill down on a specific weekday or weekend, what were the specific diseases that the children were getting. So we thought that this dashboard would give them a clear picture. And with the help of this dashboard, they can, arrange their resources accordingly, better prepare themselves for the future, and of course it would also help with the cost and efficiency of the hospital performance. So this is what we have from the data set. We do have two stories. The main story that we are trying to depict is the pediatric emergency department visits and the length of stay by age. So which age impacted the maximum length of stay? Coming to pediatric emergency department service, as said earlier, the data that we have is for the year 2016. The latest data that we had was for the year 2016, and we wanted to analyze and give the power to the management, higher level management team to see visually where they can improvise their services. So this is an interactive dashboard. If you observe, whenever you click, you can drill down on data. For example, January, February, March, and based on the tooltips as well, you can understand that what were the number of records that were encountered over weekend, and what were the numbers encountered over weekday. This would also drill down on another chart of ours based on the month. So for example, if I want to see what were the ER services provided in the month of March, I can drill down on data and can see that this is what the picture is. So ER services provided in the month of March were around 42.26%, and no emergency department services provided on weekend were 57.74%. So what we observed while creating these dashboards, that relatively the emergency department services encountered a larger number of cases compared to the no ER services on weekend as well as weekday. So even though if you are able to see that, okay, there is a lesser percentage of ER services provided in the month of March over weekend, but that's still not a smaller number. If you see, there is a little difference between the ER services that are provided on weekday and weekend. If you further want to drill down on what were my ER services and what were the diseases specific to those the cases encountered, you will be able to see in the graph below that the deaths reported over weekday were the traumatic brain injury, bacterial infection, suicidal ideation, septicemia. So these are some of the diseases that cause the deaths over weekday, coming through the emergency department services. Also, for if you want to see for the no emergency department services, you will be able to see what were the diseases that caused the death. So we believe that giving this power of interactivity to the user, to the upper level management, or whoever it will be useful, they will be able to analyze what kind of diseases they should be prepared, what kind of resources they should be prepared with in the future in order to tackle the situation and improvise the length of stay of the hospitalizations. Next, coming to the picture, of course, this picture is definitely going to change now concerning the coronavirus cases that we have. We will definitely be seeing a different deaths reported due to different diseases. So this is something that we can do in future. The length of stay. So as I said earlier, we have the data for the age below 20 years, for the children below 20 years, as well as neonatal age. Now, what is neonatal age? Basically, neonatal age is the first 28 days of when the child is born. So we wanted to analyze what were the length of stay by age for these children for the entire age range. And we did observe that the neonatal age, that is the age less than a year, children with age less than a year, was a lot. The length of stay was a lot. So this can give an idea of where the hospitalization resources can be improved again with respect to neonatal age, and also where we can utilize the scientific researches based on the diseases that are mostly encountered for the age group of these children. Coming down, we can see that we do have this picture. Further, we drill down into to see what the inpatient stay and what the length, how much the length of stay constituted for the first 28 days when the baby is born. And if you see, 83.09% of the length of stay was occupied by the neonatal age. So this gives us a clear picture as to where the concentration should be with respect to resources and what kind of disease we can analyze to see if there's something that can be done. So the key elements that we used over here to analyze all this data were basically the patient demographics, the hospital characteristics, such as the teaching status, census division. What were the expected payment sources? Was it Medicaid, Medicare, the total charges, and the severity, and prior to 2016? So this all helped us, helped with the analysis on Tableau to give a clear picture of where we can go ahead with the research. So we wanted to basically do a machine learning project. So before starting with any machine learning project, if to understand the depth of data, what each data element means, exploratory data analysis does help us to know how a variable in the data set relate to each other. So this gave us a clear picture, as well as helped us in building the dashboard for the higher level executives. So there is a paucity of evidence related to predicting length of stay. So much of the limited evidence which does exist is from observational studies, which may suffer from biases. So therefore, it is vital that information about the factors which predict the length of stay is identified from multiple studies to provide a robust evidence for future research. So this is like a future prospect for us, an overview of machine learning approach and ongoing research to determine the length of stay for the inpatient care, especially for the pediatric inpatient care. So we did come to know the relationship between each variables from the data set, what is the importance of each variable, how it impacted the other variables from the exploratory data analysis. The next step that we are working on is the data wrangling and cleaning. So we have many open source tools such as Python, Anaconda, Spider, Jupyter Notebooks, where you can implement Python-based data frames such as pandas and Python-based libraries to predict the length of stay or to predict any kind of machine learning algorithms, using machine learning algorithms. So this is where we are working on. Next step would be the feature selection. Feature selection is an important part in the machine learning. Now, the data set that we have has around 100 elements. So to reduce it, it becomes very difficult to predict based on these 100 elements. There is a factor which impacts the performance. There is a factor that limits the use of various machine learning algorithms. So in order to cut down on those data elements, we use a technique such as feature selection. I would not be going much into depth because there is a lot of to explain under this each of the category. So this is basically where the data engineer works, the data wrangling, cleaning, ETL processes, and the feature selection. The next would come is machine learning modeling. Now, in our case, we have continuous variables, continuous numerical variables, where we can use the machine learning modeling specific to the supervised machine learning modeling. We do have a target variable, that is the length of stay. And based on the independent and dependent variables, the dependent variable here being the length of stay, a future prospect is to implement supervised algorithms such as decision forestry, regression, Bayes theorem. So this is all that we can implement on our ongoing data set to predict the length of stay. And of course, the final stage would be the predictions and insights. We do have the performance metrics by which we can evaluate and compare which machine learning model did our best. And of course, no machine learning algorithm will give you 100% answer that, okay, yes, this kind of, when you encounter this kind of disease for this particular age of a child with these demographics, this is going to be the length of stay. No, this is not going to be it, but we are trying to find the best model that will give us an approximate length of stay based on all the independent variables that we have in our model to, of course, predict and give insight. So this is something that would be useful in near future. And the last thing is, of course, education is the passport to the future, for tomorrow belongs to those who prepare for it today, by Malcolm X. I truly go by this quote. This is because from my personal experience, when I never knew that I will be landed in data analytics. I didn't know that there was such a field called data analytics, data science, and I didn't know that I was going to land there while studying in India for Bachelor's of Engineering. But when I came into Accenture and I started seeing the real world problems, I started interacting with the business and how my work contributed to their gain. So this is where I felt motivated, and this is where I understood that, okay, we have to come out of our comfort zone, and you cannot just be in your comfort zone and do the technologies that you're doing continuously. To come out of it, I that is the reason why I did Masters in Information Systems. I knew that, okay, there's something more that I can do in data, and there are new evolving technologies that are coming up, and I can help the business more by implementing and suggesting solutions and giving the key performance indicators to them. So you have to come, this is what I believe, you have to come out of your comfort zone in order to control your future. So this is where you can control your future. So not only did I streamline my career in data analytics, now I'm trying to streamline, okay, how can I combine data analytics with cloud? How can I try to bring the business which is on premise over the cloud and deliver the same insights, deliver the same business goals carrying on cloud. So especially during this time when there is so much remote work going, I think this is the best. This is going to be the near future where you will be delivering everything based on the cloud platform. So yeah, just come out of your comfort zone and you will be able to control your future.
Well, thank you, Tanvi. It was great having you with Virtue Testing, and we wish you all the best. I hope to see you again in future.
Thank you so much, Victor. I think this is a great platform and a great opportunity to deliver your ideas, your thoughts, and I really thank you for that, for giving me this opportunity. Thank you so much, Victor.
Thank you. Take care.